Good afternoon, students. Today we are going to learn drying, which is a mass transfer operation. We are going to study drying in details today. आपको पता ही है कि अब हम लॉकडाउन में हैं, तो हमारा टाइम हमको यूटिलाइज करना है. सो लेट्स स्टार्ट विथ मी. तो ड्राइंग क्या है? व्हाट इज़ ड्राइंग? So basically it is a mass transfer operations in which moistures of a substance, basically which is solid, is removed by use of a thermal energy. We previously studied distillation and other operation in which we use the thermal energy to separate the substances. In this drying, we remove the trace amount of water from solid or solid material. It involves transfer of liquid from wet solid to an dry medium. So it is a mass transfer operation. Heat is involved in this, so we have a two phase. First one is a solid phase, second one is a gas phase, and mass is transferred from solid phase to gas phase or vapor phase. So in drying operation, thermal energy is used, whereas there is another operation called evaporation. There is a difference between this term drying and evaporation. Both are the separating operation, but in evaporation we reduce a trace amount of solvent and remove it from solid and concentrate the material, whereas in drying we solid water removed from the solid. So that is the basic difference between them. Now, as a removal of moisture contained by means of thermal energy, there is a cost issues. Many drying equipments have a cost issue, but it is essential for our final product. Now, many manufacturing industries such as chemical industries, agricultural industries, food industries, pharmaceutical industry, textile industry have to use this kind of drying operation. These drying operations are carried out because of following reason. First, to reduce the transportation cost. Why this transportation cost? Because if we have a final product in a liquid form, we have to carry them from one place to another in a tanker or a pipeline. But when we have a dry product, we just pack it into a packages and we transport it whenever we want. Second, for purifying the crystalline product so that solvent adhering to the crystal is removed. Now, there is another operation called crystallization, in which we remove the trace of solvent to crystalline solidify the product. In that, the solvent that we don't need, we remove it by using this drying operation. Third, for making material more suitable for handling and storage. Handling it on storage of dry solid is easy. Fourth, to meet the market specifications of solid set by the customer. Now, many customers want their product in a dry powder state or in a solid pellet form. So, they need to be specified by the customer. So, we have to convert it. For providing definite properties to the material. If we have a slurry, then it has water content, so it cannot use easily. If we transform it into the powder form, so we can easily use it. And the most important is a corrosion, prevent corrosion due to the moisture. You all know that if we have moisture contained in a material, will cause a corrosion problem. So by using drying operation, we reduce the corrosion problem. Okay, so now we are going to see general definitions which we are previously learned in humidification and dehumidification operations. Now first, moisture content. Now what you all know that air is a mixture of moisture and different types of gases. Now air contains the moisture content, which can be defined on two different bases. First is on weight basis. First, it can express as a ratio of weight of moisture to the weight of a wet feed material. Suppose we have 1 kg of 1 kg of a material which has a moisture, and in that x kg is a moisture and 1 kg of dry solid. Then we have a moisture content on weight basis is equal to x divided by 1 plus x. Now on percentage basis we only add 100% into it, so we can get the moisture percentage on weight basis. Now moisture content on dry basis, it can express as the ratio of weight of moisture to the weight of dry solid present in a wet feed material. If we have feed material x kg and 1 kg of dry solid, then on dry basis kg of moisture divided by kg of dry solid is equal to x. Now the difference between these two is that in wet moisture content weight basis we have to take the weight of solid, total weight of a solid, but in dry basis we have to take only kg of dry solid. So that is the big difference between that. Now our third definition is moisture content x star. The moisture content of solid that is in a thermodynamic equilibrium with its vapor in a gas phase under a specified humidity and temperature of hot gas or air is termed as equilibrium moisture content. It represents the limiting moisture content to which a material can dry under a constant drying condition. Now this equilibrium moisture content is the moisture content that can be removed by using the thermal energy and which is in equilibrium with its vapor, so we can break it by using the thermal energy. Now second definition, bound moisture. It is a moisture in a solid material which exerts a vapor pressure less than that of a pure liquid at the same temperature. Now these definitions means we have to know about the vapor pressure, partial pressure of vapor and gas mixture. The partial pressure and vapor pressure may give a big difference to this moisture content. Now unbound moisture content. It is a moisture held by a solid in excess of equilibrium moisture content corresponding to saturated humidity. It is primarily held in a voids of solid, and its vapor pressure is equal to pure liquid. Now these are definitions you have to mug up. Free moisture content. Now it is a moisture contained by solid material in excess of equilibrium moisture content. It has a given temperature and humidity. It is a moisture content that can be removed by drying. It may include both bound moisture and unbound moisture. Now critical moisture content. Critical moisture content constant rate period, falling rate period. We will see that topic in a next topic, but let's finish these two other definitions. Dry bulb temperature and wet bulb temperature. The dry bulb temperature is the temperature of a vapor gas mixture recorded by the thermometer whose bulb is kept dry is called a dry bulb temperature. and a wet bulb temperature. The temperature recorded by the thermometer whose bulb is kept wet by wrapping a wet cloth in the open air is called a wet bulb temperature. Now here a equilibrium moisture curve is given in which all the moisture, bound moisture, unbound moisture, free moisture, equilibrium moisture are reported as a equilibrium curve. So in that curve, in this curve, we have a graph between relative humidity of a gas and equilibrium moisture content. Relative humidity I previously explained you in a humidification chapter, so you have an idea about it. So in this equilibrium curve you saw that moisture content, as increasing the moisture content, the curve rising on the axis and we get a curve. In this we have a X star R region. It is called equilibrium moisture. This moisture is permanent in the drying operation. We cannot remove it by drying operation. Now let's see the portion S, which is a free moisture. We can remove it by using a thermal energy. Now the portion P is a unbound moisture. Portion Q is a bound moisture. In portion Q, your equilibrium vapor pressure is less than that of a pure liquid, and in region P we have a equilibrium moisture content is equal to vapor pressure. So that's the explanation of that curve. Rate of drying curve. Now this is the most important theory for your exam perspectives. Now what is drying curve or rate of drying curve? So it is basically a graph of rate of drying versus moisture content. How the rate of drying behaves according to the moisture content, that is our drying curve. So we have a drying curve as shown in figure. We have a falling rate period, constant rate period, warming up period. Okay, so first our graph is start from this point A. It is a warming up period. When we have a solid with moisture content, we put it in an oven, then it starts like that. Its rate is increasing gradually up to point B. Now after that we have a constant rate period. In that, constant moisture is removed by constant moisture is removed, means rate is constant. After this constant rate period we have a falling rate period. Now this falling rate is divided into two portions. First is unsaturated surface drying and last one is initial internal movement moisture control. Now unsaturated surface drying means we have a saturated point here, and after that we are giving a thermal energy. Then unsaturation is happen on the surface of the drying, so we have unsaturated drying up to here. After that moisture content is less, so internal movement of the solid is start and internal movement relieves the moisture up to this X star, which is a equilibrium moisture content, and this is a moisture content to be held on the solid surface. So this curve is called rate of drying curve. You have to explain it in a longer version as per your marks. Okay.